This plane had to complete a long journey before arriving at Frankfurt Airport. And what's more strange as it may sound, this monster began traveling before it was even born. After all, each A330 consists of 6.5 million parts and components produced by 1,500 companies in 30 countries all over the world. The A380 is the largest passenger aircraft in the history of world aviation. It's manufactured by Airbus. The maximum capacity is 853 passengers. The length of the liner is almost 73 meters. The wingspan is almost 80. The height is 24 meters. In fact, this is the height of a 9-story building. And the area of the 2 passenger decks totals 550 square meters, which is larger than the area of a football field. The A380 is such a complex and high-tech machine that none of the EU countries were able to take on this project alone. As a result, this giant aircraft came into creation thanks to its 4 parents: Germany, France, Spain, and Great Britain. The wings are made in the foggy Albion, the tail is made in the homeland of Columbus, and the final assembly is done in France. But the most complex and crucial stage, the production of the fuselage sections, was entrusted to the meticulous and scrupulous Germans. The fuselage of this giant consists of 3 huge sections: a nose, tail, and middle. It is also called the center section. All of them are manufactured here in a huge special hangar near Hamburg. A lot of time and thought went into selecting the location. On the one hand, there had to be an airport nearby, as many components arrive here by plane. On the other hand, the presence of a navigable river was necessary in order to— mind you, why a future flying monster needs a river, you will find out a little later. As a result, the plant was built on the banks of the Elbe. The fact that it flows into the Atlantic Ocean played a decisive role in the choice of location. To accommodate more passengers on the plane, Airbus designers decided to make it a full 2-story plane and not with a hump like on Boeing's, for example. This is where the 8 in A380 comes from. This figure somewhat resembles the cross-section of an airplane fuselage. Also in the East, it is believed that the number 8 brings good luck. And the first customer of these giants here was actually Singapore Airlines. The fuselage sections are assembled on huge slipways. They're somewhat reminiscent of scaffolding. The parts of the casing are thoroughly inspected, checked, then technological hooks are screwed onto them, which are then used so a crane can lift the parts. Afterwards, individual segments are assembled on the slipway to form a finished part of the fuselage. It all looks like a huge 3D puzzle. In just one day, the body of the future section appears from a dozen pieces. There are 6 assembly slipways in this hangar. The section simply transfers from one to another, gradually drowning more and more in wires, cables, lines, hoses, pipes, tubes, air supply systems, and internal lining. Basically, what you have here is a giant conveyor belt where a section spends several days at each stage. The aircraft body consists of only 75% aluminum. The remaining 25% are special composite materials. For example, this part is the plane's tail, made of especially durable fiberglass. Based on its characteristics, this material is pretty much the same as aluminum, but significantly lighter. Theoretically, it would be possible to make an entire plane out of this, but it would simply be very expensive. Besides, according to developers, the trickiest part in creating the aircraft is the issue of reducing its weight. This monster is so huge that its own projected weight could have prevented it from flying. This problem was solved not only thanks to fiberglass, but also augmented aluminum alloy. As a result, only 40% of the center section consists of volatile metals, while the rest is made up of composites. After the body of the sections is ready, it is carefully wrapped from the inside in a coat, I guess. It's a special heat-insulating material due to its ability to retain heat. A thin layer of such fiber replaces a 10-centimeter layer of glass wool. But that's not even the main thing. In the event of a fire, God forbid, of course, this material is capable of holding temperatures of several thousand degrees for 90 seconds. Every square centimeter of this aircraft has been planned down to the tiniest detail. The thermal insulation material, for example, arrives in segmented pieces based on special templates. Even if the worker wanted to, he wouldn't be able to attach the wrong segment to the casing. It simply wouldn't slot in with the others. So this shirt will fit our monster like a glove. We all know, of course, that an airplane is a tough nut to crack, but I'm afraid we can't even imagine how complicated it is. For instance, when we enter the passenger deck, we can't even begin to presume what's under our feet. Now you have a unique opportunity to see this. Hundreds of wires, 1,000 contacts, but you know what? This is just for starters. You should see what's happening under the ceiling. One A380 has 530 kilometers of wires. In the cockpit alone, there are about 10,000 of them and about 40,000 of their various connections. They are everywhere. They weave through the entire plane from nose to tail. Every second, huge amounts of information and hundreds of volts must be transmitted through them. These are like the nerve endings of our monster. By the way, main connection lines are duplicated 3 times. If a short circuit occurs in the main line, the backup will cover it. Should the second fail, the third will take its place. And that means that mainline wires have to be fitted 4 times over. All this in conditions of extremely limited space and severe time pressure. To get to any given connection, workers sometimes have to use rather exotic tools. A dentist mirror, for example. But to be fair, this version's a little bigger. Fitting the electrics is the most difficult stage of equipping this section, which is why it spends the most time on this slipway. The huge structure is then transported further. At this stage, air supply and air conditioning systems are installed inside the section. By the way, none of the air ducts are metal, aluminum, or even tin. They're made of fiberglass. And again, because it is lighter. In fact, all the air in the A380, and that's 1,500 cubic meters, is completely exchanged every 3 minutes. As a result, absolutely everything is installed in the sections except the inner lining. After all systems have been checked tenfold, along with wires, pipe connections have been tested, only after this are the ends of the huge sections covered with fabric and the huge components of the aircraft rolled out of the hangar onto the pier. And here it becomes clear why the flying monster needs a river. Naturally, the logistics for transporting the components of an A380 are crazy. Here in Hamburg, several sections are loaded onto this specially built barge, after which it goes along the Elbe to the Atlantic to the UK, where 2 aircraft wings will be overloaded. Now at that point, this ship turns around and heads back to France. The A380 is a monster that doesn't just fly, it's a monster that unites. The sections of the aircraft are so huge that there's no other way to deliver them to their place of final assembly other than by water. Huge fragments are loaded onto one of 3 River Sea-class ships specially commissioned for the A380. And so that onlookers have no doubt about their grand purpose, the side of each barge proudly boasts this inscription. Once again, due to the huge size and the high fragility of the sections, they did not even try to build a crane in this transshipment port. The parts of the future aircraft move inside the ship themselves, and to do this, the stern of the ship simply tilts down and the pier sags towards it, like a huge elevator. A huge number of different devices, tools, and machines were created specifically for the construction of the A380. One of them is this tow truck. Its main unique feature is that all of its 48 wheels, by the way, can rotate 90 degrees. And that means, if needed, this platform with a load capacity of tens of tons can actually move sideways. And this is a very important quality in conditions of limited loading dock space. The platform drives under the section, lifts it, carries it into the hold, and then places it there and moves out again. The whole operation takes about 15 minutes. And the most amazing thing is that the driver of this miracle car, there he is. Yeah, he doesn't even sit in the cabin but walks next to it and looks to see if everything is okay. A huge trolley that he controls using a remote. In just a few days, this huge ship with parts of the fuselage inside will be in Bordeaux, France. At the seaport of Pauillac, the sections will be loaded onto one of 2 river barges and sent up the Garonne. 100 kilometers of canals, sluices, and overhanging ancient bridges. In some places, the distance from the top of the section to the bridge truss is only 20 centimeters. However, never in the entire history of the A380 have any emergency incidents occurred with the fuselage and sections on the road. In the river port of Langon, the aircraft parts are again loaded onto road trains, and now they have to travel another 240 kilometers on the road to Toulouse, to the final assembly site. The path of our monster's components runs through small French towns. To minimize inconvenience to residents, the convoy of 6 huge trailers and 30 escort vehicles moves only at night. During the day, this huge convoy, stretching several kilometers, rests in specially constructed parking lots. But once darkness descends, everything here begins to move again.
Okay, we'll do it as we always do. The weather conditions today are good, the road is dry, visibility is excellent. Arno, you're going to go in the front. Don't forget to remove the barriers in the cities. Speed is 15 to 25 kilometers per hour, no more. Good luck, everybody.
Each of them knows what and when to do something like the back of their hand. The drivers never change their order in the convoy. The trailer with the right wing of the plane always comes first. That's just how it came about. When the A380 parts were transported for the first time, that was the order. And since then, there have been no incidents, and they decided to leave this order for luck.
I transport different loads, but I consider this task the most interesting, albeit the most difficult, as all of it requires constant focus. On top of that, I'm first driver, but my 2 navigator operators always help me. One goes in the front, the other behind. They constantly radio in, telling me to drive a little to the right or a little to the left, but that's mostly necessary in cities, of course.
The route along which the Airbus night convoy moves is closed off. A police car, technical service vehicles, and a motorcycle escort are up ahead. In France, they don't even escort the president's limousine. About 40 minutes before the convoy passes through any city, the support group walking in front prepares the path, removing any interfering cars and sweeping the road clear. There shouldn't be any bumps whatsoever. Then they unscrew the posts separating the roadway from the pavement, and all this is done surprisingly calmly and, of course, politely.
All right, and there we go. Good evening, sir.
Good evening. While passing through the city, the convoy's speed is reduced to 5 to 7 kilometers per hour. Huge sections of the fuselage literally hang over old French houses. After all, they're at least twice as tall as them. And in some places, the distance from the load to the wall is reduced to several centimeters. Here, Here, nothing less than pinpoint precision is required from the heavy-duty truck drivers. A glittering line of trucks driving through narrow French streets. The giant components of the A380 here in Provence have long been an attraction of sorts. Despite the late hour, of course, many local residents come out to see the spectacle. For them, this night convoy is like an Airbus carnival. Always at the same time, somewhere around 2 a.m., the convoy enters the territory of the A380 assembly site near Toulouse. Come dawn, here the main stage of creating this giant aircraft will begin, joining the sections. It's like Toulouse was specially constructed to be the A380 production site. Firstly, it is a very romantic city. It is also called the Pink City because of the peculiar color of the bricks. Secondly, it was here that Antoine de Saint-Exupéry, the famous writer who made millions of people around the world look at the sky differently, was born. Just like our monster, the A380. While the fuselage sections that arrived here at night are being unloaded near the main Airbus assembly hangar, one of the world's largest cargo planes is landing on the tarmac of the local Blagnac airport. It's branded the Beluga, a name it received due to its external resemblance to the enormous deep-sea inhabitant. The powerful transporter has brought the tail of the A380 from Spain for assembly. Most transport aircraft load and unload from the tail, but this plane is unique in every single way. Its nose ramp folds up, and the part of the future monster simply slides out onto a special platform, which slowly and carefully approaches the plane. Only one component of the A380 struggles to fit into the belly of this huge whale, this beluga, the tail. And that's despite the fact that the diameter of the cargo compartment is 7.5 meters and the volume is 1,500 cubic meters. This fish has a large stomach. Usually the most difficult thing is to properly secure the cargo inside the hold. In all honesty, the beluga has a rather exotic aerodynamic shape and controlling it is no easy feat. And if the balance of the aircraft is suddenly off, it will be almost impossible to land it. A special person is responsible for correct placement of the cargo. Oh, and he flies together with it, evidently to feel a greater responsibility for the work he's done.
We always try to use the aircraft to the utmost of its capabilities. My colleagues and I always calculate what the maximum load might be. It's a fascinating and very challenging job. The cost of a mistake here is our lives and tens of millions of euros. But I am proud to fly on this airplane, of which there are only 6 in the world.
The beluga spends at most an hour in the hangar, unloading, a quick inspection of the aircraft, checking all systems, and its wings up and back. In Spain, the next tail of the next giant aircraft in line is already waiting for its turn. Curiously, the parts of the future aircraft that the beluga brings here to the plant in Toulouse are carefully sheltered and even enclosed in a very thick fabric. The area of this little case here is hundreds of square meters, to protect the elements of the aircraft. There should not be a single scratch on them. Thanks to its impressive size, the beluga can take on board 47 tons of cargo at a time. But because of this, its range of movement is very small. It's more reminiscent of the range of some light aircraft. This giant can fly only 1,700 kilometers. Still, for the distance from France to Spain, that will more than suffice. that all the components of the A380 have arrived in one place, all that remains is to assemble them. For the monster plane, Airbus had to build a monster hangar. The weight alone of the metal structures used to build this workshop is 34,000 tons. That's 4 times the weight of the Eiffel Tower. The width of the doors through which the planes roll in and out of the hangar is 90 meters, and there are 8 of those doors. It comes as no surprise that this structure can be seen with the naked eye from space. In total, 3 aircraft are assembled in the assembly shop at the same time. In turn, the 3 main assembly slipways are set up here. When the fuselage parts take their place, the slipway, with a total weight of 1,200 tons, seems to envelop the future monster from all sides. The 3 sections of the giant aircraft's fuselage, plus 2 more wings, are assembled on this slipway like some kind of children's construction set. Added to all that, this monumental work takes only 5 days. Here, by the way, is the place where the 2 parts join. Note that one section slightly falls over the other, so they end up overlapping. Here they are fixed with clamps like this. The sections are drilled and fashioned with rivets like this, and there are 3,000 of them here. So, oddly enough, the place where the 2 parts of the fuselage join is one of the strongest and most durable places on this plane. Still, riveting different sections to each other isn't exactly rocket science. That being said, you do have to tinker with connecting and labeling all the electrical and computer systems. It is this incredibly painstaking and vital job that takes up most of the time.
We have several hundred people working here. With such a workforce, of course, it is very difficult to control everything. Tens of thousands of rivets need to be fitted and thousands of wires soldered. But we've established a setup in which everyone does their own part of the job, and then an inspector comes and checks it all multiple times.
How many times?
How long does a plane spend here?
4, maybe 5 days.
5 days?
Yes.
That's not long. I'd even say it's really fast.
Oh, yeah.
And in these 5 days, you connect all the sections together, install, and even connect all the internal systems, yeah?
Yes, that's right.
Incredible.
This is a very stressful job. The longest we've held a plane here was 7 days. But that only happened once.
One of the trickiest operations is joining the wing consoles to the fuselage. They're moved to the desired position by crane beams, and then precise laser corrections are performed. Around 4,000 high-strength bolts are used to connect one wing to the fuselage. And that being said, fastening the sections is no easier. So that the worker, God forbid, does not mix up and suddenly drills holes in the wrong place, there are these templates here. They're simply applied to a certain part of the fuselage, secured, and then with a special gun like this one here, holes are made through the holes in the template, into which rivets are then inserted. It turns out that there are tens of thousands of rivets in one place, and each one has its own place. What's more, there are also several thousand such templates on the assembly slip, and each one suits only a certain place on the aircraft body. Nowadays, an A380 lands or takes off around the world every 7 minutes. These giants transport more than 1 million people a month. The machine seems to be selling itself. Buyers are lining up and leaving with a smile. But Airbus continues to test and implement more and more new systems on this aircraft. They can only be fully tested in the air, and that's why here at the plant, there's a special plane, a guinea pig aircraft, which tests all new engineering ideas on itself. To be honest, the inside of the test A380 bears little resemblance to a passenger one, but rather a submarine or flight control center. All these complex computer systems monitor 20,000 different parameters every second. Suffice to say, the total length of the cables that connect the servers is 200 kilometers. Now you can imagine what a headache it becomes for on-site engineers when the connection in at least one wire from this bundle here, for example, is torn, and he needs to check every single one to find the fault. When an aircraft needs to simulate a flight with passengers, it's loaded with water tanks weighing a total of several dozen tons. And by the way, these pilots still have parachutes. The crew of a regular passenger plane, contrary to popular belief, of course, does not have them.
This test aircraft is simply vital. It did most of its job, of course, when the A380 was just about to go into production. At that time, everything on it was tested, from avionics to determining noise and cabin temperature. But even today, we don't stand idle. Practically every day, we take to the air to test a new engine or a new system.
The process of testing a new item on this aircraft to serial introduction usually takes years. Aviation is both a cutting-edge and rather conservative industry. The cost of error is too high, so all ideas and materials are checked dozens of times. And this means that on those planes, now being assembled in the Airbus hangars, systems are being installed that were invented and tested several years ago. The final silhouette of our monster has already taken form on the main slipway. Now it is being retrofitted with various units and mechanisms. This device will control the flaps of the A380, raising and lowering them, and with their help, the plane itself either gains altitude or descends. On conventional aircraft, this mechanism is much smaller. However, this is not surprising. The area of the flaps alone is the same as the entire area of a wing on an AN-24. Several teams are working in parallel on the assembly slipway. One is responsible for the tail, the other for the right wing, the third for the left, and so on. It's important that everyone keeps in time with their schedule. After all, just one sluggish group of 4 or 5 people could delay the delivery of the entire liner, and this spells colossal penalties. One of the most critical areas is the installation of the landing gear, which, by the way, contains Russian titanium. This is generally the only element of this huge aircraft where products from our industry are at least somehow used. But to be fair, this can be deemed as a very crucial unit element. It takes on a huge load when landing. And of course, titanium is one of the strongest metals on Earth, the only one capable of handling the task, provided that the wheels don't fail. A set of tires for the A380 consists of 22 huge wheels with a diameter of 1.5 meters each. On top of that, they're so powerful and the pressure inside is so strong that you can't even believe that the sound is rubber, so it completely feels like wood or, I don't know, plastic. And yet the load on these wheels is so great that the footwear for our monster has to be changed periodically. And that means about once a year. The planes that are on the slipways have yet to be painted. After assembly is complete, in this slightly unpresentable form, they fly on their own from France to Germany, where they'll be given the final polish. The only detail that's already shimmering with all the airline colors is the tail. In fact, there's an online camera installed under the ceiling in the assembly shop. The customer of the aircraft can see the feed from it, and from the tail, he can determine which of the 3 aircraft is his and what state of readiness it's in. Generally, the mechanism for selling an aircraft is approximately the same as when selling a car. Next to the main hangar, Airbus built something like a car showroom, or better yet, an air cabin, specifically for potential customers. Here, the buyer can get acquainted with the equipment, make some tuning selections, even order the color of the upholstery. Any whim for your money. Hello?
Good afternoon. Welcome on board the A380.
Please show me what you have here.
Yes.
So if you want to follow me, we'll see some...
Well, do you see how much space there is? I mean, name another plane where you can encounter something like this. It's hard to believe that this is a plane. It feels like the living room of some reception hall. If you look at the cabin, this is the widest cabin in the sky.
The special showroom displays a variety of A380 cabin layouts from economy to business, first, and premium class. Cabins like these are considered the highest of chic. They're called suites here. Essentially, it's a small 5-star hotel room with a bed, an armchair, and of course, a TV and a small table. If you wish, you can even invite someone into such a cabin. It won't be crowded, but that said, you won't achieve complete privacy here, as the side wall of a suite is only 1.8 meters high. According to aviation rules, stewards must see what is happening to a passenger at all times.
So now, as you can see, we're entering the business class cabin, and here we have beautiful armchairs that actually convert into beds.
Everything moves, everything goes lower. I feel like I'm in a spaceship in some kind of sci-fi movie. Yeah. Sweet. There's even a TV. I mean, well, yeah, I'm in the future. It'd be nice to fly in these conditions somewhere from, I don't know, Moscow to Vladivostok. Not like I usually do. Comfort is perhaps the main trump card of the A380 developers. This is where the main emphasis is placed. Airbus is especially proud that this monster has the quietest cabin in the history of world aviation. Standing at the top deck bar and listening to music, it's easy to forget that you're even on an airplane. What's more, in-flight comfort is created not only for the passengers, but also for the crew. Another of the numerous features on the A380 is that it's claimed to actually have the largest and most comfortable crew rest cabin. But it appears to be big only by French standards, as I have to tilt my head a little. Nevertheless, it's got everything you need to relax: a bed, a TV, even a phone. Basically, it's pound for pound a small hotel room. But so that the crew members don't forget that they are still at work, the affectionate French attach the sign "one person only" near each capsule, just in case. In fact, the dimensions of this compartment are standard for any A380. Everything else can be changed. Now, the most popular layout is the passenger compartment divided into 3 different classes. In this case, that means the aircraft has 525 seats. But you can also order a setup where there will be only economy class throughout the plane. Then the number of seats can be increased to 853. However, for some reason, no one has ordered that one yet. Still, the interior and the seat are, as they say, add-ons. The interior of the A380 will again be fitted in Germany, and the plane must fly there itself. To do that, after assembly on the slipway, it will have to pass an extremely tough exam. Once the aircraft is fully assembled, it needs to be fully checked to make sure everything is correct. Interestingly, this process takes the same amount of time as the assembly. It happens in this hangar, plus they also install the engines. As a result, about 3, sometimes 3.5 fully finished aircraft are rolled out from here per month. I mean on average, of course. That means only 35 to 40 monsters are assembled here per year, and the concern's order portfolio includes hundreds of aircraft.
This is where we carry out our testing. Extensive checks are carried out over several weeks to ensure that the electrical and hydraulic systems, as well as moving aerodynamic surfaces such as rudders and wing mechanization elements, are fully operational.
A thorough and lengthy check is performed on all engine systems. A big plane needs a lot of thrust. And although the A380 can fly confidently even with one failed turbine, it's better not to cause a heart attack. The Air 380 has 4 hearts, giant engines each packing 70,000 horsepower. And each of them burns hundreds of liters of aviation kerosene in just 1 second. Interestingly, these turbines for the A380 can be made by 2 completely different firms competing with each other. The customer himself chooses which engine he needs, and any of them will fit here like a glove. At the same time, the A380 is the most economical aircraft in its category. It's the only long-haul airliner that consumes less than 3 liters of fuel to transport a passenger 100 kilometers. Compare it with the consumption of your car, and you'll understand that flying works out cheaper. Well, at least when it comes to fuel. After all checks are complete, the aircraft moves out of the workshop and onto the airfield to perform what's known as a pressurized cabin test. It's akin to pressure testing batteries in our homes, which utility workers carry out before the cold season sets in. During this operation, excess pressure is created in the cabin, which significantly exceeds the permissible value for operation, to identify the possible presence of leaks. If everything is fine, pilots are brought on board for the final test. Their task is to make the first test flight. In other words, to get this monster up on its wings. The A380 cockpit is almost the same as any other Airbus aircraft. The company specifically makes them the same so that pilots can more easily transfer their flying knowledge from one type of aircraft to another. But they made an exception for this monster. Overall, the set of instruments is the same, but the displays are almost 1.5 times larger, as a big plane needs big monitors. Romantic French pilots claim the first flight for any A380 is like a first kiss. Unique, each one has their own, and it's always beautiful. After all, only from this moment on can this huge and complex airline be rightfully called an airplane. In the Frankfurt terminal, passengers are still waiting for their invitation to board. The calm, unabashed appearance of the A380 outside still leaves no doubt about its reliability. Meanwhile, inside the monster, tempers are flaring for real. During preparation for takeoff, you can't help but feel that onboard the plane is complete chaos. There's a huge number of people, stewards, technicians, maintenance personnel moving around the plane at great speed and constantly doing something. Laying out pillows, checking food, installing new armrests, headrests, repairing seats. In fact, everyone here has their own job to do, and everything is like a well-oiled machine. It takes only 1 hour to prepare this giant airliner for departure. At the same time, the technicians outside are refilling the aircraft with water and fuel, charting the batteries, checking the landing gear and engines, and conducting an external inspection of the fuselage. While the plane is parked, its engines are switched off, so the air conditioning and heating systems aren't working. And that's why these air ducts here are connected to the plane, and hot air is pumped through them directly into the cabin. This is done so that when people get inside the plane, it will be warm, all for the comfort and convenience of the passengers. After the technicians give the green light, the captain comes aboard. This time, he personally checks all control systems again, verifies the route, and inputs the flight map into the onboard computer.
You know, this is a really good plane, the best I've ever flown in. It intuitively feels the pilot, and should the pilot do something wrong, it will always highlight the issue. On top of that, it obeys a person without question, and the handling is surprisingly easy. Basically, comfort-wise, it's like a Mercedes, while it handles like a Ferrari.
The time has arrived for the passengers on the Frankfurt-Los Angeles flight to begin boarding. Everything is strictly according to schedule. 3 epic paths guide people onto the huge plane in a matter of minutes. Walking along the 2 decks of this giant, they don't know that there are tens of thousands of wires under their feet. Behind the ergonomic upholstery are concealed a multitude of cables and pipes. And when they sit down in an economy class seat, they don't pause to think about the cost of this machine being several hundred million euros. Anyway, all that doesn't matter now. The main thing is that this airliner will lift them into the air in just a few minutes' time. And don't be afraid, this is a good monster. We're at a coal mine, also known as an open pit mine, a giant hole in the ground going hundreds of meters deep. Ever since man realized that coal can be extracted not only on the ground but also by open pit mining, these mines have been getting bigger and bigger, just like the machines that operate there. More coal to the motherland. This Soviet motto is still relevant here in Kuzbas. In this open pit mine alone, several full trainloads of this fossil fuel are mined every day. But before you can get to the coal, you must first lift and haul away hundreds of thousands of tons of waste rock. Now that is a job for a real monster. That is a job for the Belaz. Coal mining starts with so-called strip mining. The waste rock under which the fossil fuel is hidden must be removed, in other words, stripped. And that's where the term originated. Most often, the rock is blown up. A huge pile of rocks, sometimes hundreds of meters long, is referred to by miners as a pit face. This term migrated to open pit mining from its underground counterpart. An excavator arrives at the pit face to scoop up the rock, and then come the dump trucks. Work at the face does not stop for a minute. In turn, the Belaz trucks around the quarry non-stop, day and night, without weekends and holidays. During shift changes, the drivers don't even turn off the engines. As a result, these undemanding and hardy monsters sometimes work for several days in a row. In winter, when the temperature here in Western Siberia drops to -45, the dump trucks are not turned off for weeks at a time. It is not an easy task to start them in the cold. But what incredible endurance must these monsters have to withstand such loads? The rock, for starters, is incredibly heavy. Secondly, it's very hard. And thirdly, it has sharp edges. As a result, in a few years, these rocks scrape at the Belaz body almost till there are holes in it. So every 4 years, this body is coated with new sheets of metal. And that's it. After that, our low-maintenance monster goes into battle again. The load capacity of this dump truck is 220 tons. During one shift, it transports so much rock from the face to the dump that it could easily fill several Olympic swimming pools. It truly is a monster. Fully loaded, it weighs more than a Boeing 747 and can literally move mountains. But how on earth is it made? These huge monsters are created by everyday, run-of-the-mill people, hundreds of kilometers from Minsk in a small town called Zhodina. Now, the choice for the location of the Giant's factory may appear a little strange to you. There are no large quarries nearby where the finished Belazes could be sent, no metallurgical plants from where it would be logical to take steel for manufacturing these monsters, and no large power plants, as after all, creating this vehicle consumes a huge amount of energy. The Belarusian automobile plant was built in an empty field near the unremarkable Zhodina railroad station. But now this station is where the world's largest quarry machinery plant is located, which is the only plant in the former USSR. The Belaz is a unique machine, so most parts for it are not purchased, but made right here. Both gearings and gear wheels for gearboxes, starting for example with this one here, which is considered to be very small, and ending with this big guy. Everything is made right on the production line. The mechanical shop alone, where the innards for our monster are made, already looks like a separate factory. In the shop, a huge number of machines are lined up in several rows, one after another, according to the production sequence. Parts are passed from one machine to another until it is completely finished. This setup was invented and built here in the 1960s. That time was an era of high motivation. Factories, power plants, and roads were being built all over the country. The superpower that was the USSR needed a lot of super machines. It was then that the Belarusian automobile plant began to manufacture the most mass-produced and probably the most famous 120-ton dump truck. These machines were literally pouring out of the factory gates one by one. It was the second youth of the Belarusian automobile plant, built right after the war. However, here today, they produce dump trucks with a payload capacity of 220 and even 360 tons. To do so, new equipment and new approaches to production are needed. The insides of these monsters are not made via a line system as before, but in one place on modern 5-axis milling machines. Essentially, the turner just needs to set the workpiece correctly, and then the computer will do everything by itself. It's not even that this machine is Soviet and old, and this one is German and new. The point is that it uses this chisel cutter as a cutting tool. In one go, it scrapes off a fraction of a millimeter of metal. And here, use this kind of cutter, it spins at breakneck speed. It's very heavy, by the way, and in one go, it removes as much metal as the chisel cutter could after several hundred moments. One of the most critical parts of a dump truck are the gears. They transmit motion from one shaft to another. There are a lot of gears or gear wheels in a dump truck, so the accuracy and speed of manufacturing these parts directly affects the production of the entire truck. After the finished part is removed from the machine, it is sent to the measuring laboratory. Each part here undergoes a strict final examination. A special device with an artificial ruby on its tip probes the item and checks its parameters against those of the electronic blueprints on the computer. Only if the deviation is within norms, that is within 1/100th of a millimeter, the part receives a maturity certificate, a certificate of conformity. Now the most interesting things are about to happen in the life of this gear graduate. Fire, water, and copper pipes lie in wait for it, literally. As you know, to be healthy and strong, you need to temper yourself. Now this statement applies to metal as well. Once off the machines, our gears are still relatively soft. Otherwise, we simply wouldn't be able to cut these cogs' teeth. So to temper the gears, they're heated in this furnace at 950 degrees and then immediately plunged into cold water. So you get the sauna effect. Basically, our monster gets the same treatment as humans do. After tempering, the gears are sent to the assembly line. Not all of them, though. Some experimental gears go to a special workshop. While their function isn't one to be envied, it's certainly to be revered. They will have to sacrifice themselves for the sake of creating new mechanisms and machines. All new parts of the Belaz undergo mandatory testing here in the so-called experimental shop, a place where they are cruelly mocked. Well, that is, they are tested, compressed, stretched, checked for strength, wear resistance, and so on. Basically, before a gear like this, for example, goes into production, about 100 prototypes will be mercilessly destroyed here. Miners demand even greater and greater load capacities from dump trucks, so the designers have to come up with even newer technological metal advancements and constantly invent innovative materials. Without exaggeration, the Belaz experimental shop is at the cutting edge of progress. From conception to implementation of an idea, it takes only several months. At one time, the introduction of a new operation principle to this dump truck became a technical revolution in itself. After all, the monster Belaz essentially runs on electricity, or rather, has an electromechanical transmission. Previously, and even now, almost all trucks have torque transmitted to the wheels through the camshaft. But here the external forces are so great that the crankshafts and camshafts had to become simply gigantic and therefore heavy, which means they needed to transmit even more torque, and so a vicious circle formed. At that point, the designers decided to get rid of these shafts altogether. The Belaz is a giant moving electrical power plant. It burns diesel fuel, generates an electric current, and transmits it through wires to electric motors, which are mounted directly on the wheels. These motors drive the entire vehicle. Pitted next to this monster, you begin to perceive the phrase motorhome in a different way. This car is really more like a two-story building. There's even a staircase, a balcony, you could say. And as your home probably does, this truck has air conditioning on its facade. Many think they're headlights, but no, they're actually air filters. Through these filters, the Belaz monster inhales hundreds of cubic meters of air per minute. That's how it ventilates its engines. It's always very dusty in the open pit, so changing the filters is one of the most frequent and most necessary maintenance operations for this monster. Otherwise, it is surprisingly low maintenance.
Yes, hello. How may I help you?
At an open pit mine in western Siberia, 1,000 kilometers away from Belarus, Jordan and Belaz trucks continue their struggle from the pit face to the dump and back again. Any damage on such a monster can stop the work of half the quarry. Therefore, the condition of the Belazes is monitored around the clock in real time in a special situation center. All the parameters of each machine are displayed on the screen. Location, load, fuel reserve, even engine temperature. The dispatcher can trace a malfunction at any time should one appear and contact the person driving in the cab at that moment.
Attention, Route 50, handover. Roger.
The cab, I must say, is very spacious. However, Belaz designers mustn't have heard of such a concept as ergonomics. Then again, it isn't needed here. Other than that, everything is like in a normal car. There's a dashboard, an onboard computer, climate control, there's even a cigarette lighter. And here's another curious thing. There are 3 pedals, but this one here's not the clutch, it's an automatic gearbox. This monster has 2 brake pedals, one is the main brake and the other is for emergencies. While it happens rarely, there are still cases when both of them fail. To avoid catastrophe, all roads in the quarry must be paved on one side with artificial mountains of waste rock. Should anything go wrong, the driver can simply steer the truck into this obstacle. The Belaz will ram into it like a bull into a gate and stop. And after that, there won't even be any dents on its sides, as its body is made of high-strength alloy steel. It can only be cut with a plasma or high-temperature gas torch. Now, the gas torch section is somewhat like a tailor's cutting table. Only instead of scissors, there is a high-temperature flame, and instead of fabric, there is a thick sheet of high-strength steel. Moving along special templates, the gas torch cuts out parts of absolutely any shape. Everything that's trendy and in season, so to speak. The parts are sent for further treatment, and the so-called trimmings are melted down. In the next section, the huge steel plates are being prepared to assemble the body for the dump truck. I would call this place the origami section. Only the sheets aren't made of paper, but thick steel. Otherwise, everything is the same. The work pieces are bent till the necessary figure is acquired, but this is no simple bending, of course. It's bending with this huge press possessing a force of, I shudder to say, 1,000 tons. The specially bent sheets are then joined together on very large welding machines. Also, the dump truck body is not completely assembled at the factory, as it would simply not fit on any railroad platform, and it would be impossible to deliver it to the open pit. The largest part of the Belaz is made of 3 parts. The left side, the right side, and the center part are manufactured separately. The customer then assembles them into one whole right on side of the quarry using ordinary bolts. This part here, which looks more like a huge bell, is actually just a gearbox cover installed on each wheel of the Belaz. Basically, this monster doesn't do things in small sizes. Even the size measuring tool is threateningly big. For example, this is how a machinist's micrometer looks. Our coal mine in Western Siberia has a problem. One of the 220-ton Belaz vehicles has suddenly stopped. The dispatcher sees this on the interactive map screen. He tries to find out what has happened.
Base control. 246 isn't moving.
The giant dump truck has a problem with its undercarriage. A boulder got caught between the rear axle wheels and jammed them. It's not a problem to remove it, but it may have damaged the tire. To check this, the Belaz is urgently driven into a box. In the repair box, technicians examine the machine. Here, the worst fears are confirmed. This monster can't work anymore for now. One of its wheels must be replaced. The problem with the wheel is this tear here. A piece of rock with a sharp edge has pierced the tire tread all the way down to the breaker very deep. I'm gonna show you. About 5 centimeters. This tire needs to be repaired immediately or it could tear right open. And a tear in a tire like this is a bomb exploding. They say it leaves a crater half a meter deep. A set of tires for this car costs about 100,000 US dollars. That's why even worn tires are not thrown away. They're patched up right at the pit face. It would be too expensive to send the wheels back to Belarus for repair. The wheels for the Belaz are made at another Belarusian plant in Babruisk. It was specially built to supply tires for heavy quarry equipment. The wheel of a 220-tonner is a one-off product and therefore almost entirely handmade. To create the so-called bracelet, the rubber base of the future tire, sheets of synthetic rubber are fitted together by hand. Layer by layer, the workers build up the base of the tire. Several different grades of rubber with different properties are used here. After vulcanization, they are all sintered into a homogeneous mass. But in the meantime, the bracelets are put on a hollow mold, one by one. To pull every subsequent bracelet on this drum mold, there is a special device here which is called an expander. The name speaks for itself, of course. Here you can now see it. It simply stretches our workpiece and puts it on this drum here, like women's tights slip onto a leg. The edges of each subsequent bracelet are tucked into the sides of the workpiece in a special way. Here, at the end of the future wheel, the so-called wings are installed. These wings are discs of especially strong steel, which will then hold the wheel on the hub. As a result, a rubber tube is obtained, which will become the inner base of the tire. Now it must be covered with an outer layer of particularly strong rubber, which after heat treatment will become the tread of the tire. For this purpose, a special mixture of rubbers is melted and mixed in a device that resembles a meat grinder, and then pushed through a so-called extruder in the form of a thin strip. After that, the rubber strip is cooled down slightly on this water-filled drum, and then it passes onwards. Ultimately, it is wound on this workpiece like a thread on a spindle. In fact, the weight of this thread is over a ton, while the weight of an assembled wheel is about 3 tons. The rubber is 15 centimeters thick, for the tire of this monster must withstand the most incredible loads. To turn this rubber tube into a workpiece, which already resembles a car tire in shape, it is molded, i.e. compressed on both sides and simultaneously inflated with air. Approximately the same thing we do when we inflate a rubber balloon. The only difference here is that the pressure inside is a little bit higher, about 3 atmospheres. It's about the same pressure we have in our radiators at home. After molding, the workpiece already acquires an appearance close to that of the finished wheel. However, now it's just a layer cake containing different grades of commercial rubber and steel wire. And it's a soft cake at that. For the wheel to be able to withstand the weight of a huge Belaz, it needs to be vulcanized. This process takes place in huge ovens called autoclaves. You can easily imagine a shortbread cookie mold. Well, it's the same idea here, only a little bit bigger. The tires end up with this tread pattern imprinted on them, and even the lettering, well, obviously, it's sort of mirrored here. It's all just like in the kitchen, save for the weight of this cookie being 3 tons, 300 kilograms. From a chemical viewpoint, during vulcanization, the disparate molecules of rubber are built into a single spatial grid. And these molecules are connected by what are known as vulcanizing agents. Most often this is carbon, i.e. ordinary soot. The wheel workpieces are loaded into the autoclave in a stack, one on top of the other. From above, the furnace shaft is closed with a multi-ton casing, and that's it. Now, all that's left is to wait. The process takes 12 hours, give or take. The finished wheel is thoroughly and meticulously inspected to root out the slightest defects. And this control is not only visual, each tire is X-rayed. It must be perfect both inside and outside. Only in this case will the tire be able to work for years and repeatedly return to service even after severe damage, as was the case at the Western Siberian coal mine. After the repair, the wheel looks like this. They simply put a kind of patch where the piercing occurred, a patch made of especially strong rubber. I've got a sample here. No matter how hard I tried, I couldn't tear it. So now this tire will last for several thousand kilometers without any problems. Touch wood, I wouldn't want to jinx it. The repaired wheel is immediately put on the hub, and the Belaz goes back to its route. Our monster's frantic race against time continues. The absolute record time for changing all 4 wheels on a car is 2.5 seconds, which was set at a pit stop during a Formula One race. But here they set their own records. This wheel assembly here, weighing about 5 tons, just takes 10 minutes to install. And here, by the way, there are 24 nuts, each measuring 41 millimeters in diameter. The nut driver generates a force of several hundred kilograms. In fact, the wheels are installed in the shop only to test run the machine, as a huge dump truck will go to the customer in parts. The tires alone take up a whole railway car. The Belaz's brakes are disc brakes. We can say pretty standard vehicle brakes. 2 pairs of pads. When you press the brake pedal, the pads compress this disc and thus stop the wheel. But the force of this compression is astonishing. It's several tons. To stop such a hulk, you have to use a lot of energy. But even more energy is needed to make this wheel rotate. The motion is transmitted to it through a huge gearbox. It's mounted on each wheel between the electric motor and the hub. Its job is to increase torque. In other words, it turns rotational speed into rotational force. The gearbox is assembled here on a special slipway. Here, gears, shafts, bearings, and so on are installed in its housing. And the assembly accuracy is so high and all the parts fit together so perfectly that, for example, this gear wheel, weighing over 100 kilograms, can be spun without any effort using just one finger. The 2 Belaz traction motors on which these gearboxes are mounted consume 1,400 kilowatts. That's enough electricity to light 23,000 light bulbs. Owing to such an amount of energy, this machine is powered by a huge diesel engine. The heart of our monster is this very powerful engine. However, it works in the same way as a normal passenger car. On internal combustion, the cylinders are V-shaped, but here we have slightly more of them, 16, and the volume of each of these 16 cylinders is almost 4 liters. The engines used to be made here in Belarus, but today they are purchased in Germany and the USA. It is hard for one small country to build such a big machine. This plant now has many suppliers all over the world. Meanwhile, the Belaz truck is hauling the Belarusian economy on its back, in every sense. If you think that the maintenance of your car is too expensive, then keep in mind that the maintenance of this monster costs about 100,000 US dollars a year. Although, no surprise there. For example, to inspect the engines, it's not enough to open the engine compartment. You need to climb inside. Reliable, simple, trouble-free, like a Kalashnikov assault rifle. This dump truck can work for years in the most severe conditions. This coal mine in Western Siberia and hundreds of other open-pit mines in dozens of countries around the world know this very well. It is a bit clumsy. It lacks grace and elegance. It is almost always dirty and has an incredible appetite. But it mines coal. It's a monster with a very brutal temperament. But at the end of the day, it brings us light and heat.
The 12 decks of the transatlantic giant named Symphony of the Seas comfortably accommodates 6,500 happy passengers. They will enjoy an incredible adventure, a journey around the Caribbean. This is a quiet and peaceful place now. You won't find pirates here, unless they're from the entertainment team, of course. Several days of unforgettable rest await passengers, but throughout their voyage, they won't ever see the hundreds of devices, machines, and sophisticated bits of engineering technology, nor the nearly 1,500 people on the lower decks of the ship that are part of a crew of more than 2,000 who will make their vacation truly comfortable and safe. We're going to turn this monster inside out for you. This will be a cruise ship program without romance, and without leaving anything out. Symphony of the Seas is in fact the largest passenger ship in the world today. It's even been recognized in the Guinness Book of Records. But what do we mean by the largest? It's not actually about the size when it comes to ships. Another liner in the same class, Harmony of the Seas, is longer than Symphony by several centimeters. But the Symphony has the largest displacement, the amount of water that is displaced by the ship due to its volume. Remember Archimedes' principle? Well, the Symphony has a displacement of 228,000 tons. That's equal to 5 Titanics. A giant like this isn't able to enter just any port. In Russia, for example, there is only one that can accommodate this ship, in Vladivostok. While the most advanced places in this regard are countries in Asia, Europe, and of course, the United States. Port Miami, Florida's major seaport. Here is its cargo terminal. All in all, it has rather modest traffic figures. About 1 million containers move through here per year, so we've got maybe a dozen cranes and just a couple of ships docked here at the moment. This isn't what this port is famous for, of course. That would be something else. That I'll show you right now. Here is the world's largest passenger terminal for cruise ships. Here, behind my back, that's not a multi-story building, no. It's the stern of a ship named Symphony of the Seas. 6,000 people are boarding it right now. And in the span of just a year, 5,600,000 people pass through this passenger terminal. That's more than the entire population of Miami. It's not so much that Americans are particularly fond of cruises as it's that Miami is ideally located. Mexico, Cuba, and the Bahamas are all just a few days' travel from here. That's why this port was chosen by several major cruise companies to be their starting points. You can see that right now 6 different liners are all preparing to leave, and they belong to 4 different operators. But Symphony of the Seas immediately stands out from the others due to its incredible size. At about the same time when a shipyard in France began to build the ship itself, several thousand miles away from Europe, on a completely different continent, right here in Miami, they began to build this terminal. Again, essentially, it turns out that the ship wasn't built to fit the size of the port, but the port was built to fit the size of the ship. The main feature of this terminal, or maybe I should say the main art installation in this terminal, is these 2 rotating propellers which are exact copies of Symphony of the Seas propellers. They each have a diameter of 50 feet, and the weight of the real ones is 200 tons each, but these are of course a bit lighter. By the way, the ship doesn't have 2 of these propellers, but 3. They're mounted on podded propulsion systems, so-called azipods. Those are made up of huge pods which are suspended from the bottom of the ship at the stern. They are capable of rotating 360 degrees, meaning azipods provide the giant vessel with easy and quick maneuverability. I will show you in more detail how all this works in the second part of the episode, but for now, I will only say that these azipods were manufactured in Finland, and then sent by sea to the French town of Saint-Nazaire, the home of the shipyard where the vessel was built. In general, Symphony of the Seas is a huge construction set consisting of hundreds of thousands of parts which were manufactured in dozens of different countries located on different continents. So it began to unite people from distant corners of the world even before the first passengers of various nationalities ever stepped on board. Boarding a ship is very much like boarding an airplane. Even these gangways, well, those who often fly, they know that they are almost identical to those in airports. Well, maybe these are a little wider. Only planes have a maximum of 2 such gangways, while the largest airliners might have 3. But here there are 5 of them. And another interesting peculiarity, those who fly know that boarding of an aircraft starts about an hour before departure and stops 20 minutes beforehand. But since 6,000 people have to go through here onto the ship, boarding begins 6 hours before departure, so that everyone has time to make it on board. This is why cruise ships almost always depart in the evening. All day long, passengers come on board, get used to their cabins, and then closer to sunset, the gangway is finally pulled back, the doors are all closed, and the ship rolls away from the quay wall. Thanks to those azipods that we mentioned earlier, and an additional tail rotor, Symphony of the Seas completes this difficult maneuver by itself, without the help of any tugboats. Only a small Coast Guard patrol boat moves ahead of it, dispersing small pleasure boats and ferries out of the liner's path. This moment, already routine for the crew, is always quite exciting for the passengers, who at the moment of departure always pour out onto the upper decks. After all, the sea, and even more so these calm oceanic waters, aren't anything like railroad tracks, and these gigantic ships are actually seen off in a very different way from trains.
Как ни шути, волнений больше, ведь ты уже не на земле. Как ни ряди разлука дольше, когда плывешь на корабле.
However, the passengers will hardly have time to feel any separation woes on the ship. This giant floating city is designed to be fun and entertaining. The liner is 1,053 feet long, more than 3 soccer fields. Its width is 216 feet, and in this huge space there are 28 restaurants, 3 swimming pools, 10 jacuzzis, a theater equipped with the most complex Broadway machinery, an ice rink, a tropical park, a water park, a fitness center, a casino, and many shops and boutiques that constantly keep tourists in a state of shock and awe and continuous happiness. It is somewhat reminiscent of something out of a fairy tale, a place where you need only eat, sleep, and drink. When you look at the map of the ship, these are posted everywhere here, you get the feeling that the ship is some kind of toy. Yes, there's 12 passenger decks. Yes, it says 2,750 cabins, but what do all these numbers mean? You only start to get a sense of it right here in the elevator atrium. Just take a look. 6 high-speed elevators transport thousands of people to a height of 229 feet around the clock. And at the same time, all this is now moving at a speed of 30 miles per hour in the direction of Mexico. Incredible. Even more incredible is the fact that the ship is directly controlled by only 3 people while it's in motion. And among them, there is no boatswain, no skipper, no helmsman. Even the captain himself isn't on the bridge all that often. Today, the people who control the ship from here, from the captain's cabin, are no longer what you might imagine, sailors with tough, salty, weathered faces. They look more like office workers, and this place resembles some kind of control room or something. And here's my biggest disappointment. This is the captain's chair. There's no steering wheel. The ship is controlled by 2 special joysticks. They're called anti-mice. In general, everything is technologically advanced, safe, highly scientific, and completely lacking in romance, for heaven's sake. You no longer have to pore over maps to plot a course. The navigation system stores all the necessary routes in its memory. The computer plots the path, taking into account the shallows, reefs, and other features of the topography of the seabed, and satellites track the position of the liner. An operator just needs to plug in the arrival time for the next point on the route, and the computer will even calculate the speed with which the ship could move. It's kind of like autopilot. The next time a person will need to directly intervene is the moment the ship approaches a port. The width of the ship, I will remind you again, is 216 feet. Therefore, side mirrors here clearly wouldn't cut it for parking. So when parking, well, when mooring that is, they use a special mooring console. Here it is. By the way, it sticks out from the side of the ship a bit, you see. It kind of hangs over the side for better sight lines. There is a second, identical control panel on the other side of the liner. Either the left or right one can be used, and that's determined by which side of the ship approaches the quay wall. The compass and binoculars found here are likely more of a tribute to maritime tradition than anything else. Mooring here, again, takes place with the help of space satellites and GPS. When the ship finally gets into the correct position, it is, you might say, tied to the pier with special ropes. This is almost the only step of the whole docking process that looks pretty much the same today as it did several centuries ago. The huge ship is held in place by means of 22 of these extra strong ropes, each about 5 inches in diameter. Right now, they're stretched like piano strings. They even vibrate a little. And here's something amazing. If you knock on the rope, you'll have to take my word for it. It's very solid. It feels like there's some kind of metal core inside. But in fact, this is not the case. The rope is woven from a variety of synthetic threads. They're very strong, they have a high elasticity coefficient, they're able to handle the highest levels of stress, but at the same time, as you can see, the rope is already quite frayed, despite the fact that it's less than a year old. It'll be changed soon. Previously, mooring ropes, or to be more nautically accurate, mooring lines, were woven from hemp. The use of polypropylene fibers is a more recent development. These ropes turned out to be much stronger, and what is even more important, they don't absorb moisture, so they're much lighter. Curiously, on these ropes from the 21st century, these shields from the 16th century, if not earlier, are still put to use. They're called rat guards and are needed to keep rats from the shore from running up the mooring lines onto the ship. Today, this small Mexican port has a real full house. 3 cruise liners arrived here at the same time, and all the berth walls are occupied. Here, Symphony of the Seas, 6,000 tourists, Norwegian Dawn, about 4,000. And lastly, a ship called Celebrity Reflection. There are about 5,000 more people on it. In total, about 15,000 people are coming ashore all at once. This, by the way, often becomes a serious headache for the staff of the ships. In the evening, when tourists come back here, relaxed, we'll say, after sampling some tequila, they have a bad habit of trying to board the wrong ship. But there haven't been any cases of someone sailing away on the wrong liner, not yet. The stewards and representatives of the Port Logistics Service work like clockwork and don't drink tequila, just like the other 2,000 crew members of Symphony of the Seas, who, unlike the passengers, don't go ashore when the boat docks. While tourists are exploring local attractions, on the lower decks, preparations for the main task of the day are underway: cooking dinner for 6,000 passengers before they get back on board. And for this, you first need to bring up several tons of products from the storage area to the galley. Usually, the entire selection of products for the cruise is loaded onto the ship at the port of departure. The liner can only take water on it interim stops, and even then, only bottled water. They are very afraid of the possibility of food poisoning here. Since thousands of people live compactly on the ship, a simple case of E. coli can turn into a real epidemic in the span of just a few hours. And even putting that aside, not all countries can provide products of the high quality that Symphony chefs require. All the refrigerators and storage boxes here open automatically with the press of a button. But there is one door whose button is behind a lock. Thankfully, I have the magic key. You've probably already guessed what's behind this door. Here it is, the holiest of holy of Symphony of the Seas storage area. Here are several thousand bottles of elite red wine. Milk, meat, seafood, vegetables, frozen products, fish, all of that and more is stored in the dozens of other refrigerators. Anything and everything that might be needed to prepare the 350 different dishes that can be found on the ship's restaurant menus. Of all the foodstuffs stored on the ship, only 2 products are honored with having their own private refrigerators. Well, simply because they are the most consumed items. First, we've got bananas. Here are plenty of boxes with yellow ones, and there are also boxes with green ones. They will finish ripening during the cruise. And the second product is the most popular. What do you think it is? I'll show you now. Eggs. 120,000 eggs are eaten on board every week. Moreover, bananas and eggs are, as economists and logisticians say, goods of inelastic demand. Their consumption rate, and hence the required plant amount, is easy to predict. Things are more interesting when it comes to the rest of the products on board. A specially developed computer program analyzes the number of passengers and their nationalities even before setting sail, and depending on that information, it gives recommendations on how many of this or that product you need to take with you on any given voyage. For example, if there is a large number of Latin Americans on board, more meat and spicy foods will be added to the menu. If there are more Asians, they'll reduce the amount of dairy products, and if Indians are prevalent, they will increase the number of curry dishes, but at the same time they will bring less beef. One of the main delicacies of any haute cuisine is of course the Atlantic lobster. Here he is, such a handsome guy. This dish, by the way, is not cheap, therefore it is very rare. And even here it's cooked, well, not all that often. It's a one-of-a-kind item, one might say, made 6,000 times every day. Each of these workers, there are mostly Filipinos working here, shells about 500 lobsters a day. Those of you who have ever shelled, for example, crayfish, can imagine how much work this entails. On just 3 decks, more than 1,000 people are employed in this huge floating kitchen, 250 of whom are professional restaurant chefs. They fry, boil, flambe, sauté, and whip around the clock and in shifts. Take breakfast rolls, for example. 12,000 of them are baked here every day. In fact, the responsibility of the cooks here is enormous. The clients on the ship are very demanding, the products are expensive, and the cooking portions are gargantuan. Therefore, the slightest mistake in the proportions of ingredients can cost tens of thousands of dollars. Well, for example, tomato soup, 160 liters of it. If it's a little bit overcooked or undersalted, that's it. Eat it yourself since no one else will. Seating and serving several thousand people in the liner's restaurants at the same time is a separate logistical task, and they strive to make it so that customers don't have to wait more than 15 minutes for an order. Several hundred waiters of 50 nationalities cope with this task, each of whom must speak at least 3 languages. And bartenders should know at least 5. Well, technically there was an exception made to that rule. In general, everything on this ship suggests that this is a high-tech structure created according to the latest leaps of science. For example, in this bar, drinks are mixed, well, probably in the most progressive way on the planet. All you have to do is make your choice on the tablet screen. So, yes, we confirm, and that's it. We go up to the bar and that's it, enjoy it. There's an old Russian song. How does it go? The robots work and people are happy.
До чего дошел прогресс, до невиданных чудес, опустился на глубины и поднялся до небес. Позабыты хлопоты, остановлен бег, вкалывают роботы. Счастлив человек.
Not bad. Another high-tech installation, though it doesn't seem like one at first glance, is a huge park with its own microclimate, which is laid out in the central part of the liner. Here, among the shady alleys, serenaded by the songs of specially brought in crickets and frogs, it's easy to forget that you are actually somewhere in the middle of the ocean. In this park, not many, just no less than 10,000 plants have been planted, from rose bushes and orchids to lemon trees. And all this grows here, blooms and flourishes. What's the secret? I'll show you. Here, for every plant, maybe I'm not being generous enough. Well, for almost every blade of grass practically, there's a special tube placed next to it, which from time to time, now you'll probably see it, yes, fresh water is sprayed out. And not just water. Now I'll show you the irrigation station. Here, through these pipes, 4 tons of specially prepared water are pushed every week. Here's the main secret. Here in this blue barrel, fertilizer is kept in here. Water passes through it, carries away some of the fertilizer, and carries it to the plants. So thanks, in fact, to this seemingly unremarkable little device, this whole huge blooming park exists. Another secret of the permanently green park is its honeycomb structure. There was no solid ground here. All the plants, from the trees to the grass, are inserted into special cells in separate segments, small plastic boxes. It turns out to be something like a huge puzzle. If one of the segments suddenly starts to get sick or dry out, it's simply changed out for a new one upon arrival at the home port. This wall of vertical landscaping in the ship's central park follows the same principle. The gardener, who turns out to be a bit of an industrial climber as well, simply climbs in the bucket and changes out the parts of the wall that he doesn't like and discards the old segments. There is no time for sentimentality. Nothing should prevent people from enjoying their time here and being filled with joy. Remember what I said at the beginning, that this episode was about a cruise ship without romance and without leaving anything out? In the first part of our look at the anatomy of the largest passenger liner in the world, we told you about and showed you why is Miami the home of this monster? Essentially, it turns out that the ship wasn't built to fit the size of the port, but the port was built to fit the size of the ship. Who are the people who run this giant, and why is there no helmsman on the ship? This is the captain's chair. There's no steering wheel. What room on the ship is the most secure and guarded? Here it is, the holiest of holy of Symphony of the Seas storage areas. And how many cocktail recipes does the least talkative bartender on the largest ship in the world know? You're not much of a conversationalist. All this was in the previous episode, and now we have even more about what's hidden inside this monster, a cruise ship without romance, but with science. And what could be less romantic on a ship than the machinery room? In the lower part of the ship, where tourists aren't allowed, day and night there's the roar of machines working in the semi-darkness, and these are what makes this entire giant city on water move. Symphony of the Seas is 6 diesel engines with a total power capacity of more than 100,000 horsepower. For a point of reference, that's approximately the power capacity of 1,200 cars. However, not even close to all of this energy is spent directly on moving the vessel. The ship consumes colossal amounts of electricity. For example, for lighting, there are about 140,000 light bulbs on the liner. Also, electricity is spent on the operation of air conditioning systems and on the production of large quantities of water vapor. Yes, despite the fact that steamers and steam engines are a thing of the past, modern liners still use steam. A lot of steam. No, it of course no longer rotates the turbines as it did, for example, on the Titanic, but steam is needed for more domestic purposes. It's a simple method for heating the water in showers and bathrooms, and it also heats different spaces when necessary. However, those aren't its main function. Steam is necessary for the heating systems for the huge fuel and oil tanks, and it's also used in fuel-oil separators. It's consumed by the turbo drives of some pumps, and, well, if it's necessary, for several other important machines on ships. It's consumed by the turbo drives of some pumps, and, well, it's still necessary for several other important machines on ships, even in the 21st century. Moreover, it must be perfectly clean so that impurities don't build up on the walls of the steam lines. Therefore, it is created from distilled water. But where do they get such large amounts of distilled water? It's produced right here on the ship using giant distillers. Here they are. There are 3 of them. The principle of operation is very simple. Well, it's basically a big tea kettle. This is where water from outside comes in. Here it's boiled, steam accumulates in the upper part of this chamber, and the sea salt settles down at the bottom. So after a while, overheated steam, there's a lot of it, enters this chamber. Here it condenses, and as a result, the finished distilled water is drained through the pipe. And the leftover salt? No, it's not used in the kitchen. They just throw it back into the sea. Several tons every day. This does not harm the environment in the slightest, since in essence, they're only turning the ocean's own salt back to itself, while keeping the moisture on board. Then the distilled water. Here it goes on to be filtered, and then it enters the boiler. Well, again, the principle of its operation is about the same as that of the boilers, which many of us have in our bathrooms at home. There is a small burner here at the bottom, and a tank of water on top. A very large tank, 5 tons, and it starts boiling in just a matter of minutes. In the end, the resulting steam is used for its intended purposes. Moreover, part of it, when it condenses again, is sent back to the boiler. This is the so-called reverse cycle. but most of it is irretrievably lost, and therefore the reserves of distilled water have to be replenished all the time. It's also needed to freeze an actual skating rink on the ship. Here you can skate during the day and watch an amazing ice show in the evening. That includes a number of Russian figure skaters. And by the way, the ice here is of a very high, one might say, Olympic quality. The ice on the rink measures in at about 3.5 inches thick. Well, surely many of you have seen an ice resurfacing machine on TV, or maybe even in person. They've got the exact same kind here, though maybe it's a little smaller than typical ones. By the way, since this ice is frozen from desalinated seawater, it doesn't freeze quite as well. And according to the skaters, this ice is softer than that on which they are used to performing on land. To be honest, it's hard for me to imagine how ice could be soft, but what is absolutely certain is it's incredibly clean. Distilled. I even gave it a taste, but it was really nothing miraculous, just your typical snow. The total weight of the ice in the arena is several tons, and a refrigeration unit is needed to freeze it. Again, it's about the same as the one used on professional skating rinks and professional arenas. Well, this one might be a little smaller. It's located, as you would expect, in the area under the stands. The principle of its operation is very simple. Through special pipes, here they are, wrapped in thermal insulation, water and refrigerant with a temperature of 14 degrees Fahrenheit are pumped to the arena. This freezes the ice layer by layer. It takes about 5 days to prepare the entire ice rink. The owners and designers of Symphony of the Seas claim that this ship is not only the largest in the world, but also the safest. There are so many different safeguards in place in its control system that it is argued it's almost impossible to lead the liner into disaster, even if you were to deliberately try to do so. Still, in the event of an extreme case, there are means of evacuating the ship on board. They have to accommodate the evacuation of all passengers and crew if something were to happen. These lifeboats, to match the ship, are the largest in the world. Each has a capacity of 370 people. There are 18 of them on the ship. Moreover, they are kept fully prepared at all times. Their fuel tanks are filled, they have a cruising range of about 155 miles. There was a special supply of dry rations and water on board in special sealed boxes. In the event of a disaster, there would be no time to bring it all from the ship. In general, everything is thought out to the smallest detail. This unsinkable and waterproof plastic jar, for example, contains signal flares. In addition to the huge boats, there are also many rafts that inflate themselves in the water and several of these high-speed rescue boats. They are used to coordinate action and quickly help people who find themselves in the water. The crew must participate in evacuation exercises at least once a month. This vessel has never seen a real red alert, but thanks to constant training, 2,000 crew members are ready for any turn of events, 24 hours a day, 7 days a week. The ship also has its own waste recycling plant. Here it is. This, for example, is a machine for pressing cardboard packaging. Here, cans are collected. Then they are all crushed into these large bricks. Cellophane is processed here. At first glance, it is a little paradoxical how they deal with glass bottles. I'll show you now. They are simply broken into little pieces so that they take up less space, and they are sorted as follows. Here we have a big bag with dark glass. Here we have broken transparent bottles, and here we have green glass. And here's what's surprising. As is everywhere else on the ship, in this waste recycling shop, everything is kept perfectly organized. There isn't even an unpleasant smell here. The creators of this ship seem to have a thing about cleanliness and environmental friendliness. In a good way, of course. For example, the liner's engines burn several tons of diesel fuel every hour. But at the same time, not black, not even blue, but exclusively white smoke comes out from the Symphony's exhaust pipes, all thanks to scrubber cleaning. Well, if to simplify it as much as possible, the exhaust gases are washed with seawater. This dirty water is then maintained and stored in special tanks until the ship arrives at a port, and only carbon dioxide with a minimum amount of soot and impurities is released into the atmosphere. Scrubbers and engines are managed from this control room. It's located in the very center of the ship, almost at the waterline itself. Therefore, there are no huge windows to be found here, like on the captain's bridge, but there are 51 monitors which display thousands of different parameters. The largest touchscreen control panel even had to be hidden in the ceiling. Here it's already pretty cramped without it. There's a special emergency phone in this control room. Well, there's a telephone for singular emergencies. Its peculiarity is that it will work in any case, even if, say, God forbid, of course, all systems here completely fail and all power is lost. By what means? I'll show you now. Good old inductive coil. This technology, well, I don't know, it's probably around 120 years old, and it's very strange to see it on this ultra-modern ship. But technology such as this is sometimes the most reliable. Hello? Bridge? Apart from that, the equipment in this control room is of a quality comparable to NASA's Flight Control Center. And the whole vessel is practically a spaceship. Sure, they're not jet, but diesel-fueled V-engines. But each weighs about 200 tons. 2 of them are 16-cylinder, 4 more are a bit smaller with only 12 cylinders. These giants were made in Italy, and then they were sent by a special convoy, first along blocked-off roads, and then delivered by sea to a shipyard in the French town of Saint-Nazaire. Building each of the 6 fiery hearts of this monster was such a difficult technological task that we decided to show it to you in more detail. That's why we're taking the reverse path to the engine, from the Caribbean Sea into Miami through France to the Italian industrial port of Trieste. The company that makes the world's largest marine engines in Italy is actually from Finland. It's called Wärtsilä. It got its name in honor of a small Finnish village where this business once originated. It's curious, but today the urban-type settlement and the Wärtsilä station of the October Railway are part of the Sortavala region of the Republic of Karelia, a typical Russian single-industry town with a modest budget. At the same time, Wärtsilä has an annual revenue of several billion dollars. But back to the engines. Each of them consists of several thousand parts. Some of them are made right here in Trieste. Some come from subcontractors. Cast and forged blanks, for example, are sent from a metallurgical plant in the Czech Republic. The so-called connecting rods come here to the plant in this form, crudely forged, very coarse to the touch. Here, they are then installed in these machines. They each weigh 330 pounds, by the way. Many of us, when we were kids, not everyone of course, in shop class did something similar, carving out various objects. It's about the same here, only the size is much larger, and the accuracy is very high. As a result, the connecting rod is worked to, well, just to a mirror shine. After the lathe finishes, the connecting rod is then married to the piston and installed in the cylinder. In general, everything's familiar. Everything looks like a conventional internal combustion engine. But in this place, you feel like Gulliver in the Land of the Giants. The size of the parts is daunting. Everyone who has ever gone over the engine of their car, seen the pistons, immediately recognized them. Well, this one, believe me, is exactly the same. Well, a little bigger. This weighs about half a ton. And the volume of the cylinder in which it works is 6.5 liters. That, by the way, is a bit more than the total volume of my car's engine. Well, all right, not a bit more, several times more. And this, I repeat, is only one cylinder, and in 2 of the engines on Symphony of the Seas, there are 16 cylinders, just like this one. And the main difficulty here is that huge parts, that sometimes weigh several tons, must fit together perfectly. After all, there is so much force and heavy loads involved that the slightest deviation or inaccuracy can send the engine off the rails, and in the open sea, that can threaten a catastrophe. Therefore, manufacturing margin errors are as severe as with Swiss watches. Well, by the way, using the crankshaft as an example, you can easily understand the principle of operation of a piston engine. Look, in this position, for example, the piston would be in the upper position, and this crank pin is also up. At the same moment, the other piston is in the lower position, and the crank pin, respectively, is at the bottom. Thus, the pistons move up and down, and the shaft rotates. Everything is very simple, but the most amazing thing is that this particular shaft weighs 25 tons, its length is 26 feet, and it's made of one single solid piece of metal. Just unbelievable. By the way, there are only a few metal laths in the world that can carve a 26-foot item like this from a multi-ton bar of high-strength alloy steel. The turner's worst nightmare here is to screw up even one detail. The crankshaft is worked on for several weeks, and it costs more than $1 million. Ultimately, after numerous checks and tests, the crankshaft and thousands of other parts are sent to the assembly area. In a few more weeks, the engine is finally ready, and now tests await it. If everything is in order, the engine is rolled back onto the ship, all technical fluids are drained, and it's checked again and again. In the testing chamber, the engine has already been checked out by numerous automated computer systems, sensors, and so on and so forth. But no one has done away with the good old visual control test. Everything here, again, is like in a car. We open the hood and look inside. Perhaps the most important difference between this engine and a car engine is that there are 12 of these hoods, or rather viewing windows. Behind each of these windows is one of the cylinders and valves connected by a connecting rod to the crankshaft. If you wait for the oil to drip down from the parts, you can simply see with your eyes if any jams or other metal defects have formed during the tests. When at this stage the inspectors give the go-ahead, the only thing left is to pack up the engine and send it to the customer. But that's easier said than done. Anyone who has ever, transported, say, a dresser knows that the most necessary thing to get that done are duct tape, some styrofoam. Oh, here we have some. Well, and a lot of bubble wrap. When moving a finished engine, everything is about the same. All protruding parts are carefully wrapped with these foam corners, sealed with tape, cling wrap, and so on and so forth. Well, in general, everything is the same as when moving furniture. There is a slight difference, though. The weight of this dresser is 180 tons. It takes a week just to get it ready for transportation. By the way, at the same time, road services and a special platform, the only one in Europe that can support such a weight and size, are being prepared for the giant's move to the port. Only here, at the very end, in the finished goods warehouse, can you begin to understand the true scale of this giant engine. Its height is about that of a 3-story building. It weighs several hundred tons and generates the amount of electricity that would be needed for a small Moscow neighborhood. The actual biggest mechanical heart in the world of the world's biggest cruise ship. And let me remind you, Symphony of the Seas has 6 of them, and although at the same time, even at full speed, usually no more than 3 of them are working, the fuel consumption is still massive, and that's why the company that owns the ship uses a little trick. At the starting point of the journey, in Miami, they take on board only as much fuel as is needed to reach the next port, where fuel is cheaper, and when they're already in Uruguay or Mexico, for example, the liner is filled up with diesel all the way. Thanks to this, the ship owner manages to save several $1,000,000 per season. However, there is one caveat. For some reason, the fuel from these countries often contains water. By accident, of course, I'm sure, but this is unacceptable for the engine. Therefore, all fuel is cleaned directly on the ship before being fed into the combustion chamber. But how can several tons of fuel be cleaned per hour and when moving at full speed too? And here, centrifugal force comes to our aid. Fuel enters these separators, which are in essence huge mixers, and it's spun at a breakneck speed. What happens in there? Water, which is heavier, is forced out to the walls, and the oil product, as the lighter portion, accumulates in the center and then enters the engine. 5th grade physics at work on the largest ship in the world. At the same time, the fuel in the separators is also heated. That makes it more runny and it therefore burns better. By the way, the liner has an electric drive. No, its powerful internal combustion engines do not directly rotate the ship's propellers. They spin generators that generate electricity. And then, along the high voltage lines hidden in the bowels of the liner, the current travels to the electric motors, which spin the propellers. This diesel-electric circuit makes the vessel more maneuverable. After all, an electric motor, unlike a piston one, can stop and change the direction of rotation almost instantaneously, and it doesn't need a gearbox. The motors, together with the propellers, can also rotate 360 degrees around their axis. Therefore, it becomes very easy to operate the liner. However, even the most high-tech devices and numerous automatic safety systems are not able to 100% protect the ship from basic human error. 3 weeks after we filmed this episode, in the same Mexican port where Symphony of the Seas stopped for an afternoon, 2 cruise ships managed to collide. Oh my God! There were no casualties, both ships even continued on their voyages, but still, this situation once again reminded me that regular emergency evacuation drills on the ship are not at all excessively precautionary. However, maybe no less dangerous than a collision with another ship would be a situation in which 6,000 passengers were left hungry. They almost seem to fear this even more here. The 350 exquisite dishes on the menus of 28 restaurants will satisfy even the most demanding customer. We already showed you how this monster's kitchen works in the first part of this episode, and perhaps at this point the question occurred to you. How can you quickly wash a large number of plates, mugs, glasses, and cutlery after dinner? On this ship, in general, all technological processes that can be are built on the principle of a conveyor belt. Well, this is logical, of course, because this is one of the most effective forms of labor organization. And here in the kitchen, the dishwasher is also one huge conveyor machine. Come with me, I'll show you. Sorry, dirty dishes are being loaded from that side and clean ones are already coming out here. The whole process takes less than 1 minute, extremely fast. Mr. Clean would be impressed. There was no other choice because after every dinner, about 50,000 dishes have to be washed, and that's not counting the kitchen utensils. Though it may seem like less than a critical machine, the dishwasher on the ship is actually such an important unit that it has a twin backup in case the main one breaks. Another one of the liner's important machines is the washing machine. It was built to special order and installed in the bowels of the ship at the time of its construction at the shipyard. A whole 2 technical decks of Symphony of the Seas have been given over to laundry. Here, about 10,000 towels are washed every day. They also tried to automate this process as much as possible. Housekeepers collect dirty towels from the rooms, sort them by color, and send them to the laundry decks. Here, they are loaded into this receiving bin. Then the towels go through the chute to this washing machine. One of the world's largest washing machines. Its length is 36 feet. And this one differs from the ones in our houses, not only in size, but in that all the cycles take place simultaneously. Here, it's soaking items. Here is the actual washing. Here is rinsing. Here is already spinning. That means that while dirty towels are entering the front of the machine, clean ones are coming out from here. And all this is happening around the clock, nonstop. After each batch of towels, there's about 100 each. Comes out of the washing machine after spinning, it looks like a large blue pill. Now, each towel needs to be shaken out, smoothed, and rolled beautifully. This step is done manually. There are mostly Filipinos working here, and for some reason only the men of this hardworking nation seem to be the ones managing to perfectly roll thousands of towels every day without complaint for months on end. And here, they also wash hundreds of sheets and pillowcases around the clock. Well, homeowners know that the most difficult thing to iron are sheets and duvet covers. It's really quite time-consuming to do with an iron, but here you have to iron 2,000 sheets every day. And that's why they installed this machine here. It not only irons the sheets, but also, this is the most amazing thing, I'll show you now. It folds them. Look, in an ideal way. Not just anyone can do that. In short, I want one of these for my house. Only thing is, I'm afraid it won't fit into my laundry room. The laundry employs several hundred people. There's more than 1,000 in the kitchen, dozens more are in the engine room and on the bridge. A huge army of the crew invisibly makes every second of the stay of the passengers on this ship unforgettable, comfortable, and safe. And yet the passengers themselves will never see most of them. Only service personnel who are in direct contact with tourists are allowed to climb up onto the passenger decks. That includes waiters, maids, bartenders, salespeople, hairdressers, and other staff. Others, sometimes for several weeks at a time, don't leave the depths of this monster and go out into the sunlight at all. But keep in mind, first of all, they are well paid for it, and second, at the end of the day, they work on the largest cruise ship in the world. And although they can't take in the incredibly beautiful sunsets of the Caribbean Sea from their own balcony, behind the walls of their cabins, which are located on the lower decks, you can hear the rush of water. Yes, I promised that it would be a story without romance, but still.
The Mi-26 is the largest, most incredible helicopter capable of lifting the greatest loads. No other country has been able to create anything of its kind. This is a very Russian helicopter. After all, it came to be thanks to one of Russia's eternal torments, bad roads. During the Cold War, nuclear missiles needed to be delivered by some means or other to faraway launch sites in Siberia and the northern Urals. The simplest way to solve this issue, and simultaneously the most complex for designers, was to create a huge helo behemoth.
The Mi-26, NATO codification named Halo, crew 5 people, maximum load capacity 20 tons, length 40 meters, rotor blade diameter 32 meters, maximum speed almost 300 kilometers per hour, service ceiling 6.5 thousand meters.
It was created exclusively as a transport and assault copter for the military. But recently, its peaceful modification, the Mi-26T, has become simply indispensable for a whole host of installation and construction works in hard-to-reach places. Wherever a super strong flying vehicle is needed, the monster Mi-26T, a super helicopter, comes to the aid. The Khanty-Mansi Autonomous Okrug, hundreds of thousands of square kilometers of swamps and untouched dense forestry. It's here where more than half of all Russian oil is extracted. Roads here can only be built in winter, when the shifting, marshy tundra freezes over. In summer, the only way to maneuver is by helicopter. The main work at this drilling station has been completed. Jump pads have been installed and pipelines have been fed to the oil well. Now, at another site 100 kilometers from here, the on-shift workers wait for the drop-off of the drilling equipment, which is now free for use. They're waiting for the Mi-26. The weather in Ugra has a mind of its own. The sun might be shining in the morning, by lunch it may be raining, and come evening there may be snowfall. But despite the capricious northern climate, the monster Mi-26 must fulfill the task it's been assigned, transporting cargo from one oil extraction site to another, including drilling equipment, cables, even houses for the on-shift workers. The only way to deliver all this is by air. And time does not wait. Every day the drilling squad stands idle totals millions in losses, which is why the cargo must be transported smoothly and quickly. The Mi-26 has 40 minutes to do this, roughly the amount of time you'll be watching this video. But how is this monster created? Its anatomy is very complex and somewhat reminiscent of the human anatomy. This vehicle also has a skeleton, skin, sensory organs, nerve endings, and even 2 hearts. But all in due time. We'll get to that later. Everything great starts off with something small, and the same goes for our monster. The birth of this amazing machine begins in a small, galvanizing plant. Here, aircraft-grade aluminum sheets, abbreviated to avially, are prepped for transportation to the assembly site. The sheet casing for the Mi-26 chopper could be branded as the skin of our behemoth. But before it's wrapped around the skeleton, these sheets need to be anodized to make them better and more durable. Remember like the fairy tale with the donkey? First a vat of hot water, then it's cold. It's pretty much the same here, only far more complex. When parts made of aluminum or aluminum alloys are oxidized, they are covered in a grayish oxide film in the form of uneven spots. This can worsen the physical properties of the metal, added to the fact that it's not aesthetically pleasing, which is why the aluminum is anodized. The essence of this process is that the same oxide film is formed on the surface of the part, only it's evenly spread and durable, preventing further development of corrosion. The main process takes place in this bath here. To the naked eye, it looks rather pleasant. It even resembles a jacuzzi in some way. There you have the bubbles. Nevertheless, I've been advised not to take a dip in this bath, as firstly, there's a current flowing through it, and it's packing a high voltage. And secondly, the liquid inside isn't water, but sulfuric acid. This is how the anodizing process received the name sulfuric acid anodizing. The aluminum part, along with a lead cathode, are placed into the cooled bath of sulfuric acid solution. The part itself is the anode. An electric current passes through the bath, the surface of the parts are heated and become loose, ultimately oxidizing evenly under the impact of the oxygen contained in the water and sulfuric acid. The sheet casing is then dipped in boiling water to crystallize the effect, so to speak. It's rinsed in cold water and then dried, practically like clothes after they've been washed. Now these aluminum sheets can be sent to the assembly slipway. There are actually several slipways. Naturally, there's a main slip where the main parts of the chopper are assembled, but beforehand, the separate pieces of the Mi-26 are created on the smaller slips. On this one, for instance, the head of our monster is made. You can hazard a guess, but basically the outlines of the future Mi-26 cockpit are coming into view. On this line, the cockpit is wrapped in panels, like a drum with skin, so to speak. It's nothing complicated, really, but the main thing is to ensure that all the elements slot firmly into the mold. Those same aluminum sheets that have been anodized are simply joined to each other tightly and riveted to the frames, the skeleton of the Mi-26. In fact, the rivets are colored differently, either red or white, and have different properties. The red sorts are a little softer, and the white ones harder. Each rivet is installed into a strictly determined hole according to the main blueprint. Basically, it all somewhat resembles putting together a colored children's mosaic. The rivets are made from that very same sheet casing, i.e. aircraft-grade aluminum. In fact, the principle of fastening parts by riveting migrated into aviation from ship construction. While shipbuilding became a welding game long ago, airplanes and helicopters are still manufactured using good old rivets. They're light and reliable, although for aviation manufacturers, installing them is a genuine pain in the backside. Literally. It's scary to say, but to assemble a single loading floor for the Mi-26, 12,000 of these rivets are used. And for each one, a hole needs to be drilled out, then the rivet must be fitted and closed up. The clamoring here is horrendous, which is why many workers use earbuds along with headphones. The first military application of the Mi-26 took place in 1984 in Afghanistan. The chopper transported paratroopers, equipment, and even motorized groups. With this monster, the Soviet Shiravi soldiers found themselves in the most unexpected places for the enemy, occupied commanding heights, and took control of mountain roads and passes. However, due to the unprotected hull, a bullet from a Kalashnikov pierced the side of the helicopter like paper. The paratroopers weren't all too in favor of the machine, even calling it a cow, a hint at the helicopter's peaceful and slightly slow nature. That said, when it came to evacuating the wounded, it simply had no match. Refashioned into a flying hospital, the Mi-26 was able to carry 60 wounded, all bedridden, along with 3 doctors in just one flight. To prevent the paratroopers' feet from slipping on the cargo floor, several thousand more spikes are attached to it. As a result, approximately 50,000 rivets are used in one helicopter. Each one is installed manually, and each one, without exception, is checked by a special inspector.
Aviation is different in that it involves people flying. We're responsible for people's lives. Everything must be done accordingly. All technological processes must be observed to the letter. Quality. First and foremost, quality is paramount.
This isn't even a milling machine, but a genuine processing center. It can measure anything and everything. Here, at the so-called non-slip stage of the assembly, the helicopter's body comes into fruition. Do you know what these are? No, they're not doors. Under them will be concealed super powerful engines. While the chopper's body is being assembled on the slipway, its filling, or the innards of the monster, are being manufactured in a neighboring workshop. The most complex parts, the manufacturing accuracy of which is measured in microns, are fashioned by cutting-edge 5-axis milling machines. This isn't even a milling machine, but a genuine processing center. To be honest, it's just a turner's dream. It's enough to simply install the workplace correctly, enter the program, and the machine takes care of the rest itself. For example, to take this hefty chunk of metal here and carve out a part like this, it takes the machine only 12 hours, while the operator is left to simply watch the magic unfold. Before the Mi-26, the world had no experience at all in creating super heavy-copters. The designers had to come up with new designs, invent new pioneering solutions for the layout of choppers, and of course, introduce new materials that were both light, durable, and sometimes incredibly complex geometrical shapes. In turn, the manufacturers were tasked with manifesting all the aircraft designers' ambitious fantasies, and they did not disappoint.
Absolutely any level of complexity and any configuration, regardless of the material type.
So there's never been a case when aircraft designers have sent you the blueprints from some parts and you've then thrown your hands in the air and said, we can't do that.
Well, up to now, there hasn't.
First of all, the blueprint goes to the workshop programmer. Based on this drawing, he compiles a program for each specific machine and specific part. It used to be the case that transferring a workpiece from a milling machine to a fraser, then from a fraser to a drilling machine, and afterwards from a drilling machine to a grinding machine would take hours of production time. Almost all operations are now done in one place. But it turns out that making a part is only half the battle, as now it needs to be measured correctly. But how? If, for example, a part is such a very complex shape, then you'll end up torturing yourself with calipers and a ruler. To that avail, there's a special control and measuring machine. It can measure anything. On top of that, it's accurate to 3 microns, which, by the way, is much less than the thickness of a human hair. Controlling a computer program, the measuring head literally guides itself along the parts, encompassing them from all sides. An artificial ruby is installed at the end of the head. A beam of light is passed through it, and as soon as the light coming from the gemstone begins to bend, the system understands that the ruby is rested against the wall of the part. This is how ultra-precise measurements are taken. All parts manufactured in this workshop are subject to meticulous measuring. As soon as inspectors give the green light, the components are sent for assembly. By the way, they're also constantly attempting to incorporate new technologies. Just 10 years ago, the same Mi-26 was assembled here differently than it is today.
Naturally, we're evolving. We're introducing some changes to our processes. We're trying to improve labor conditions for our workers and, in turn, reduce labor intensity and increase productivity.
One thing that remains unchanged is the quality and reliability of this machine. It is operated in the most extreme conditions, at high altitudes when its loading powers drop sharply due to thin air, in the desert when sand has been clogged in the turbines. But perhaps the most extreme place where this behemoth has ventured is the Chernobyl nuclear power plant. It was the Mi-26 that dropped tons of water and a special liquid onto the smoking reactor, neutralizing the radiation. Later, this monster participated in the construction of the sarcophagus over the third power unit, and it was only thanks to this huge helicopter that the first responders managed to reduce the impact of the nuclear disaster on the environment. On the main slipway, all the individual parts of the machine are joined to each other. The cargo floor of the side, the tail boom. In about 2 weeks, all the parts, just like the pieces of a huge three-dimensional puzzle, will combine into a single whole and turn into a completed fuselage. Afterwards, the body is rolled out, and they begin to piece together the next machine on the slipway. Here, at the so-called non-slip stage of the assembly, the helicopter's body comes into fruition. Several dozens of thousands of additional rivets are fitted, doors are hung, and the internal partitions are installed. Basically, you end up with an almost finished fuselage. The only thing, as you can see, is that it doesn't have a head yet. That will be attached to the body of our monster a little later. This is done to ease transportation of the fuselage from one workshop to another. Let's not forget, the head of the Mi-26 weighs a hefty amount and is also the most important part. Like with a person, all the control systems of this huge machine converge into it. Almost the entire helicopter is made of very thin and light aluminum, but it still weighs 29 tons and carries about 10 tons of fuel. It's no surprise that this monster is one heck of a gas guzzler. For example, do you know what this is? Nope, it's not a door, but a hole for the exhaust pipe. Everything about this helicopter is very large. In turn, the engines that must drive it are also huge. The decision was made to position them in the upper part of the hull and carry them forward a little to balance the considerable weight of the very long tail boom, which was forever attempting to rear the helicopter. Here in this area, in the upper part of the fuselage, are these flaps. They're called hoods. The same name as a car hood is used here because under them will be hidden super powerful engines, each packing 11,500 horsepower. The power is enormous, but it still needs to be converted into the very lifting force that keeps the chopper in the air. It turns out that the monster helicopter needs a powerful main rotor, the largest rotor in the world. They withstand colossal loads, for they must generate enormous lifting force. The surface of the longeron becomes so even, you can look at yourself in it like a mirror. It's so powerful that here in the workshop, for instance, turning it on is strictly prohibited. It can fry all radio electronic devices. When you stand on the helicopter, you begin to realize that it truly is a monster. The Mi-26 has a single rotor design, meaning the entire load isn't distributed over two rotors, like for example on the Chinook, but falls on the shoulders of 8 giant blades attached to the main rotor transmission.
Mikhail Leontievich Mil once said that if there are new blades, then there is a new helicopter. So, these blades were created to replace the Mi-6 helicopter.
Each blade on this monster exceeds 50 meters in length. They differ from the screw wings of the previous Mi-6 not only in size, but also in design. For the first time ever, a production technology based on composite materials was employed specially for this helicopter.
As we know, the whole world is now switching to composites, as composites are more reliable than metals. Metals are prone to corrosion, and the durability characteristics of composites are often higher.
The beating heart of each blade is a titanium longeron, or as it's called here, a pipe. Once it arrives at the helicopter factory, it's meticulously polished on grinding machines that have been specially designed and manufactured for this operation. The longeron is polished to perfection using bog-standard metalwork sandpaper. The process takes 5 days, and during this time, hundreds of meters of strips like this are completely scrubbed off. But in the end, the surface of the longeron becomes so even that you can look at yourself in it, like a mirror. After polishing, the internal stress of the metal is removed from the pipe. To do this, the entire longeron is tapped with small metal balls. After this treatment, the entire surface of the pipe is equally stressed, and the likelihood of cracks forming is significantly reduced. Parallel to this, the so-called plumage of the helical wings is gathered at the blade plant. A little later, it will be joined to that very titanium longeron. The blade is only hard on the outside. Inside, it's filled with porous material. This here is called a cell block, but it's really just paper infused with a special resin. However, since this paper is assembled into a structure reminiscent of a honeycomb, the block turns out to be incredibly durable. The honeycomb block is covered with textilite, coated with epoxy resin, and sent to the oven. After all the materials have sintered into a single hole and hardened, the finished segment is glued to the longeron. As a result, this means that one blade consists of 26 such segments. They withstand colossal loads, for they must generate enormous lifting force. But surprisingly, thanks to their cellular structure, they are incredibly light. This complex composite segment weighs only 1.5 kilograms. The finished blades are sent from the workshop directly to the airfield. They're hung on the helicopter at the very end when the other parts are finished. Meanwhile, the installation of the main systems is completed in the assembly shop. The fuselage is finally joined to the cockpit. The engines are installed under the hoods. The installation team and electricians attach thousands of wires to the dashboard and solder tens of thousands of contacts. Afterwards begins the long and grueling process of fine-tuning the equipment. The huge machine should respond to any human actions just as organically as a violin responds to a musician's bow.
We bring things to life. We're like doctors. We listen, we examine, and I always have my own slogan that our work is the work of why, meaning that every time, every day, I do the same thing again and again, but I ask myself, why is it working this way today and not like it was yesterday?
Bringing a helicopter to life takes several weeks, during which possible hiccups such as system errors are discovered and fixed, and meticulous work is performed on every single block, along with every soldering contact.
All right, Vanya, look, I didn't get a spike in AC mode, so could you please jump into the cockpit and turn on the range on the transponder control panel? Turn on AC mode. I'll give it a test from here, and if it works, I'll give a signal, okay? All right, great. Okay, let's go. Let's be quick, okay?
Yevgeny Belaz has revived more than a dozen Mi-26s. Surprisingly, all the helicopters behave in their own way and have their own personality. Each monster has its own whims and shortfalls, which Yevgeny corrects on Earth, before the monster takes to the sky. Here, being a great electronics engineer doesn't cut it. You need to have instinct and intuition to understand what is going wrong in the kilometers of nerve endings circulating through this huge machine. It's a difficult job.
Of course it's difficult. It's very difficult. It's very difficult, and what's more, it's a complex combination of simple devices that are simple at first glance, and then the transition to very complex circuit technology.
On top of that, this circuit tech is constantly being improved. More and more new instruments are installed on the chopper that are lighter and more accurate than their predecessors. The transition from light bulbs to semiconductors alone shaved off hundreds of kilograms in weight. The only part of the Mi-26 fuselage that isn't made of duralumin is the nose cone here. It's made of textilite and coated with what's known as radio-transparent paint, and all because a very powerful weather radar is hidden under this cone. Its radius of action is 300 kilometers, and it's so powerful that, for example, here in the workshop, turning it on is strictly prohibited. It can fry all radio electronic devices. After installation is complete and all operation systems have been checked, the helicopter is handed over to the test pilots. It takes about a month from the moment the sheet casing is anodized till the vehicle is rolled out of this hangar. In fact, if you put a Boeing 737 passenger plane next to this monster, the helicopter will be longer. When you stand on the helicopter, you begin to realize that it truly is a monster. Its length is 40 meters, and by the way, this is the only helicopter in the world whose tail boom you can safely walk along. But is it safe? It's a little scary for sure. After all, the height here is about 5 meters. The helicopter is tested in conditions that are as close as possible to combat conditions. Here they are, the two turbo propeller hearts of our monster. On their first flights, the pilots take along parachutes without fail, as you never know, just in case. The Mi-26 crew consists of 5 people: a commander, co-pilot, onboard flight engineer, navigator, and an onboard technician. 4 people usually embark on the test flight. This is enough for test flights, although they're often even more extreme than standard flights. The helicopter is tested in conditions that are as close as possible to combat conditions. Token loads are placed inside the machine, 4 of these heavy cubes weighing 2.5 tons each. There's a total of 10 tons here. But another detail is that on their first flights, the pilots take parachutes with them without fail, as you never know, just in case. These are the people tasked with teaching our behemoth to fly. The first steps taken by the Mi-26 on its journey into the sky are like the first steps of a child, steady and cautious. It all resembles a morning gymnastics routine.
Ready? And a 1. And again. 2. And again. 3. One more time. 4. Now the other side.
At first, the chopper simply hovers over the field, then attempts a 360. Afterwards, the pilots practice flying forward with the nose, then forward with the tail.
A sharp bow. Now give me more.
All this is done at a low altitude so that in case of an emergency, the vehicle won't crash and the crew will be unharmed. These exercises are first performed by the commander from the left seat and then by the co-pilot from his side.
And we're done.
That'll do for the first time. The test flight lasts only about 5 minutes, but that's enough time for experienced pilots to understand what kind of future lies in wait for the machine. Is she?
Everything's wonderful. The machine's completed her first flight. She'll be working for a long time for the good of the people.
As soon as the pilots disembark the Mi-26, the technicians envelop it from all angles. Even if the pilots have no complaints, the mechanics will still dig their hands into the monster. Literally. After the first test flight, all the machine's components and mechanisms are thoroughly checked. First of all, naturally, the engines. Here they are, the 2 turbo propeller hearts of our monster. They spin the largest rotor in the history of helicopter aviation without breaking a sweat. Its diameter is 32 meters. Never have engines of such power been installed on helicopters, which is why everything is checked, from the oil pressure and blade temperature to whether the turbines are fastened to the main body. If everything is in order, the helicopter goes on another test flight, but this time it's a real exam. The Mi-26 needs to fly a distance of several hundred kilometers and return back.
Despite the size of this machine, operating it is rather straightforward, by no means any harder than flying a standard light helicopter. The designers did their best to make it possible to carry out such hefty, important tasks, such as transporting cargo on an external sling inside in the cargo compartment, while simultaneously maintaining the easy handling.
After the test flights are completed, the Mi-26 is handed over to the operating company. These monsters fly all over the world, from Canada to Australia, from scorching Africa to the freezing Russian north. This Mi-26 transported the cargo to the faraway drilling site in Ugra right on time, meaning that consumers will receive their oil bang on schedule. Thanks to these timely efforts, gasoline will appear in our cars, public transport will operate, and petrochemical factories will issue their products without interruption or delay. The Mi-26 is one of those monsters that holds the modern world on its shoulders, that in every sense of the word, raises our standard of living.